Next point in the operator, that is bitwise operator. Okay, so there are different bitwise operators. Bitwise operators. These bitwise operators are first bit shifting operator. Bit shifting. In bit shifting operators, there are again two types. That is left bit shifting operator and right bit shifting operator. There are two types of bit shifting operators. Shifting, these are also bitwise operators because these operators perform operations on bits, 0101 bits, not on the whole value of a variable. Performs the operation on the single bit. So this type of operators are called as bitwise operators. In that bitwise operators, first type is bit shifting operator. Bit shifting operator is divided into two types: left shifting and right shifting bitwise operators. Left shifting bitwise operator is denoted by this notation, and right shifting bitwise operators are denoted by this notation. Okay, after that there are again some bitwise operators in that and, or, XOR. Okay, these are again some types of bitwise operators. These are not bit shifting operators, these are only bitwise operators which performs operation on single bit. Okay, so and is denoted by this notation, or is denoted by single pipeline, and exclusive or is denoted by this carried operator. Okay, so single and is a bitwise and. Single pipeline is a bitwise OR. Okay, this triangular notation, this is called as exclusive or XOR operator. Clear? So if two AND together, this is called as logical AND operator. This is called as logical AND operator. Two double pipeline, this operator is called as logical OR operator. So this is logical OR operator. If two pipelines are there and single pipeline is there, then it is called as bitwise OR operator. Okay, clear? So this operator performs operation on two operands bit by bit. Okay, and here this or AND, two ANDs and two ORs, these are logical. Okay, so when you want to connect two conditions in if or any loop statement, at that time these logical and OR operators are useful. But if you want to perform operation on single bit, then and OR, that is bitwise operators are useful. Clear? Okay, so we study first bitwise operator, that is left shift and right shift bitwise operator, and what is the use of that. So first is bit shifting operator. First in that left shifting operator, what is the use of left shifting operator, how operation is performed, and what is the result of that. Clear? For that we take one example. Our program starts from main function, void main. Okay, after that CLR, SCR, clear screen. Whenever we use the some variable, at that time you can declare the variable at the first line of your function. Okay. Next, what is the next statement? For and header files include std io.h header file, again hash include con io.h header file. Okay, that is necessary. After that main function starts, clear screen. Take one example, one variable, that is integer a. Assign the value to that variable as a 10. So this is called as variable initialization. When you assign some value to the variable, that is called as variable initialization. And when you don't assign any value to any variable and just declare, that is integer a semicolon, that is called as variable declaration. Okay. Next, what is next? Comma. Suppose second variable b. So a left shifting operator. Left shift is this notation. This is called as left shifting operator. A left shift by 1. Bit shifting operator is also a binary operator. So it performs the operation on two different operands. So here one operand is a and second operand is 1 and gives the or returns the result. You want to store that result, whatever may be. If you want to add two numbers a plus b, then you want to store the value or result into some variable. So how you write a plus b, whatever may be the operation, and the result is stored into c. So like that, a plus b, and whatever be the addition value is stored into c variable. Similarly, that a left shift by 1 bit and store this result into, say, stored into b variable. Okay. After that, printf b is equal to percentage d double quotes complete comma b, name of the variable. So here instead of percentage d, whatever may be the value stored in the b is displayed on the console. Last statement is get ch. After that, main function get completed. Okay, save this file using leftshift.c, compile it, run it. Now, what is the result of this program? What is the output on the console? So this is console, and the output on the console is only one statement is there. Printf, one statement is there, which is displayed on the console. That is b is equal to and value. So what is the value stored into b? So before that, how this bitwise operator is work? Okay. So we first a. What is the value in the a? It is 10. 10 means bit. 10 means all 1 0 1 0. What is the value of 1 0 1 0? 10. Okay. How we calculate? First is 2 raised to 0. Second is 2 raised to 1. Third 2 raised to 2. And fourth is 2 raised to 3. Add it. All value. But if it is 0, then it considered as a 0 value. So these two are 0. So only 2 raised to 3 means 8 and 2 raised to 1 means 2. So what is the value in decimal? 10. Okay. So 1010 is a binary representation of 10, decimal 10. So this value is stored in. This value is stored in where? On the RAM. Okay. So represented horizontally. This is one block reserved for variable a. Okay. How many bytes are there? Total 0 to 15 bytes are there. Last bit is in, means last bit is for sign. Okay. Positive number means last bit is set to 0. So it is positive number. Okay, and all other bits 0, 1, 2, 3. What is the value? 1, 0, 1, 0. And all other bits are 0, 0, 0. Okay. This is the representation of bind 10, decimal 10 into the RAM. Okay, and that location, logical name is A. And this location having some physical address which is in hexadecimal form. Okay, मी सांगितलं होतं पृथ्वी जशी आपण डिवाइड केली तर ती फिजिकल ॲड्रेसेस काय असतात? लॉन्जिट्यूड, लॅटिट्यूड्स, रेखांश आणि अक्षांश, आणि प्रत्येक लोकेशनला त्याचं काय असतं? लॉजिकल नेम. मी सांगितलं RIT, ओके, किंवा राजाराम नगर हे या लोकेशनचं काय लॉजिकल नेम आहे, बट फिजिकल ॲड्रेस इज देअर, दॅट इज लॅटिट्यूड अँड लॅटिट्यूड काहीतरी असणार आहे प्रत्येक लोकेशनला. ओके, तर this is the representation of the 10, decimal 10 in the binary format. So after that, what is the left shift operator? What is the meaning of left shifting? Means you have to shift one bit to left. Okay, so this is right hand side or left hand side. Okay, and this is the right hand side. Okay, left shift means you have to shift all these bits to the left side by one bit. So insert 0 at the right hand side and shift all the bits to the left hand side. So it is called as left shifting. By how many bits? Only one bit. So what is the result? Shift 1 0 1 0 to the one bit left. Means here is 1 0 1 0 and insert 0 at the end. So this value, now this value is assigned to what? Variable b. Okay, so that value is assigned to what? Variable b. So what is the value in decimal now? This is 0, no count. This is also 0, so no. This is 2 raised to 2. Again 2 raised to 3 is 0. This is 2 raised to 4. 2 raised to 4 means what? 16. And 2 raised to 2 means 4. 16 plus 4 is equal to 20. And when you display the value b is equal to percentage d, so what is the result on the console? b is equal to 20. This is the working principle of bit shifting operator. But number, first give number, after that left shifting operator, and how many bits you want to shift to left, that number. So here we want to shift that number a by only one bit. Okay, when you shift any number by one bit to the left, then that number becomes number into 2. Only one bit. Number into 2. That is number is 10. 10 into 2. What? 20. If you want to shift the number 2 bits to the left, then what happens? What is the result? 14 is the result. That is, whatever may be the number, multiply by 2 raised to 2. How many number of bit shifting? Number is 2. You want to shift number by 2 bits to the left. So it becomes, this is the general formula, that is a raised to n. General formula is a, that is number which you want to shift to the left, multiply by 2 raised to n, where n is the number of bits shifting to the left hand side. Okay, so here 2 bits shifting, so it is a into 2 raised to 2. So a is already given 10 into 4, so it is a 40. Means what? 2 bit shifting means what? Here 1 0 1 0 and insert 2 0 from the right hand side. Okay, here the bits remain same as it is 0 0. Okay, no change to that bits. So what is the final value? This is bit number 4, that is 2 raised to 3, and this is bit number 1 2 3 4 5 6. 6 means 2 raised to 5. Okay, 2 raised to 5 means 32. 2 raised to 3 means 8, that is 40. Understood what is the meaning of left shifting and how it works? It works on the particular bits, not on the whole number. So that's why it is called as bitwise operator. And these are shifting. Bits are shifting, so it is called as bitwise shifting operator. Either left shift or right shift. आता बघा, लेफ्ट शिफ्ट ऑपरेटर काय करतो? वन बिट ना जेव्हा आपण काय करतो, नंबरला लेफ्ट शिफ्ट करतो, तेव्हा तो नंबर मल्टिप्लाय बाय 2 raised to 1. इफ 2 बिट्स असतील तर नंबर मल्टिप्लाय बाय 2 raised to 2. इफ n बिट्स न शिफ्ट करत असेल तर नंबर मल्टिप्लाय बाय 2 raised to n. दैट इज द जनरल फॉर्म्युला. अंडरस्टूड? लेफ्ट शिफ्ट करणे म्हणजेच काय करणे? सिंपल भाषेमध्ये त्या नंबरला 2 न मल्टिप्लाय करणे, किती बिट शिफ्ट करायचे तेवढ्या पॉवर 2 raised to n. Understood? And why it is called as bit shifting operator? Because that operator performs operation on the bits, individual bits. So this is called as bitwise operator, and these are two shifting operators. So first is left shift operator. Okay, next, second one, that is right shift operator. What is the meaning of right shift operator? Same program, no change. Okay, B is equal to right shift means this notation. This is called as right shift operator. Right shift by one bit. Okay, this is the problem. So, what is the output? Again, right shift. This is the left hand side. Initial value is 1, 0, 1, 0. This is all other bits are set to 0, 0, 0. Okay, this is 15-bit number. This is 0 bit. 15 bit is reserved for signs. 0 means positive number. Let's see. Now, left shift, right shifting operator. Right shift means what? This bit, shift this bit to the right and add new bit to the at 14th location. Insert 0 at the 14th location and shift the bit to the right hand side. So after shifting it by one bit to the right hand side, what is the result? This is original number, that is A. After that, this is a B number where we want to save that number. So what is the result? 1, 0, 1, because this number is discarded or deleted from this, and what other all bits are set to 0 as it is. So what is the value now? 2 raised to 0, 2 raised to 2 means what? This is 0, so don't consider it. 2 raised to 0 means 1, 2 raised to 2 means 4, so it becomes 5. It becomes now 5. Understand what is the meaning? Okay, so if it is shifted, means what? If the number is shifted, right shifted by one bit, means that number, whatever may be the number, is divided by 2 raised to n. N is the how many numbers you want to shift that number to the right. Okay, by one bit, only one bit. A, what is A value? 10 divided by 2 raised to 1 means what? 10 divided by 2 means what? 5. So 5 is the clear. Right shift operator divides that number by 2 raised to n, and where n is the how many numbers you want to shift to the right. Clear? Understood what is the meaning? Okay, so if it is shifted by 2, number A, that is 10, is shifted right by 2 bits and store the result into B variable. Shifted by 2 bits means what? Again, this 1 is discarded. Okay, and 0 is inserted from this side. So number becomes now only 0, 0, 0, 1, 0. That is the number remaining. So what is the value? 0 means 0, 1 means 2 raised to 1. So it becomes now 2. 2 raised to 1 means 2. Means what is the original number? 10 divided by 2 raised to n. N means 2. So it becomes 10 divided by 4 means 2.5. But only consider integer number. Only consider integer number. Because we want to store it to integer part. B is which type? Integer. So don't consider floating point value, only decimal point or integer part. So it is 2. So what is the conclusion part? When we shift any number to the right by one bit or n number of bits, that means that number is reduced by number divided by 2 raised to n. Clear? Where n is the number of bits shifted to the right. Understood? What is the result? So these are the bitwise operator, and it is also called as bit shifting operator. There are two, left shift operator and right shift operator. These are operated on the only bit, single bit by bit, so it is called as bit shifting operator. Clear? One more important point is bit shifting operator perform operations on only integer and character data, not on the double and float values. Understood what is the meaning? Left shift किंवा right shift किंवा bitwise operator, कुठलाही bitwise operators हे कशावर परफॉर्म होतात? फक्त इंटिजर आणि कॅरेक्टर डेटा टाइप्स वरच ऑपरेशन परफॉर्म करतात. क्लियर? फ्लोट किंवा डबल जर व्हेरिएबल असतील आणि तुम्ही लेफ्ट शिफ्ट आणि राइट शिफ्ट ऑपरेटर वापरले, इट डज नॉट वर्क्स ऑन द फ्लोट अँड डबल. सो वी विल स्टॉप हियर.